and welcome to a video tutorial working our way through algebra word problems. Specifically, I wanted to go over a particular kind of problem that comes up as you're getting into distance, rate, and time, but it involves a boat in a river current, and it goes one way, it goes with the current and goes faster. The other way, it goes against the current and goes slower. So you'll also see this problem, both airplanes against the wind and airplanes with the wind. It's a common type of word problem, and until you've kind of seen how to approach it, it can be really, really confusing at first. So let's take a look at this problem and talk about how to solve it. A riverboat is able to travel at a top speed of 20 miles per hour. It regularly makes a trip up and down the river between two cities. On the way down with the current, let's mark that, it takes the boat 3 hours to make the trip. That looks like a time, so I'm going to mark that with a T. But on the way back against the current, it takes the boat 3 hours and 40 minutes. That's another time on the way back. So let's see, it goes slower against the current. The water is pushing it, slowing it down. We are asked to find how fast is the current. Let's highlight that question. How fast is the water current, both pushing the boat one way down and going against the boat on the way back? All right, my standby, tried and true measure, is I like to draw a picture. Let's visualize what's going on here. So I draw a little line. There's my river. At the end is one city. At the other end is another city. So we've got our boat, and I'm going to let's make some water here. And I'm going to say the water current is going this way. And I'm going to use C for unknown current. So the arrow means it's flowing from one city to the next. All right, so we're told that when the boat goes down with the current, it takes 3 hours. So I'm going to mark it as a time of 3 hours. But on the way back, it takes longer. So the time on the way back, I'm going to mark that down here, is 3 hours and 40 minutes. But I need to be consistent with my units. So 40 is 2/3 of 60, so I'm going to change that to 2/3, 3 2/3 hours. All right, what else do I know? I know the boat goes 20 miles an hour. Now here's how we link these two things together. Downstream, if the boat's chugging along, my rate of speed is that 20 miles an hour that the boat can go, plus it's going with the current, right? The current's making it go faster. So the rate of speed is actually 20 plus C, the unknown current. And it does that in 3 hours. On the way back, however, that boat is coming back against the current. Its rate of speed, R, is going to be 20 minus C. So there we go, 20 minus C, 20 plus C. That's how I take into effect the current pushing and pulling and affecting what's going on with my boat speed. All right, we haven't done anything with distance, but I know the distance down has to be the same as the distance back. So let's mark that and let's start to put together an algebraic equation. If the distance down is equal to the distance back up the river, I also know that distance equals rate times time. That's this tried and true equation relationship between distance, rate, and time. The distance I travel is equal to my rate of speed, how fast I'm going, times how long I'm going. So in this particular problem, let's substitute rate times time for each of my distances. So on the rate down, we know that my rate is 20 plus speed, 20 plus C, that's my rate of speed, and he goes for 3 hours. So that's I'm substituting that in for the distance down, rate times speed. On the way back, my distance is rate times time. It's going to be 20 minus C, because it's a slower rate of speed, times a longer amount of time, 3 2/3. And there we go. We've just set up an equation with C as my variable, the river current, and I can rearrange that, distribute, do stuff, and I can solve for C now. All right, let's go ahead and do that. I'm going to distribute the 3 to get 60 plus 3C, and I'm going to distribute 3 2/3 to get 73 1/3 minus 3 2/3 C. All right, I've got C's on both sides, so let's add 3 2/3 of C to both sides. And I'm also going to subtract 60 from both sides. I'm going to move things around, rearrange everything I've got here. That goes to 0, that goes to 0, and we have 6 2/3 times C equals 13 1/3. Now I'm bypassing a lot of this fraction stuff. If you need to review your fractions, you can pause this at any time. Look back at one of my other video tutorials, specifically working with adding, subtracting, multiplying, dividing fractions, but I really want to focus just on solving and getting C here. So at this point, 6 2/3 times C, I'm going to divide both sides by 6 2/3. Those divide out to 1, and we see that C ends up equaling 2. Well, there we go. We just found out that the river's current is 2 miles per hour. So that's what our units are. We got miles, we got hours. So that river is flowing along at 2 miles per hour. So it makes the boat speed 22 miles going downriver, but it makes it only 18 miles per hour going back upriver. All right, hopefully that's a good, helpful example for you of going up and down the current and dealing with how that affects rates of speed.